Here I have 23rd question of evaluating limit, and this question is really a conceptual question because it's completely based on the basics of limit. So I will suggest you, my dear friend, be a little bit focused, and I hope you have all the concept that we learned till this time. Alright, so here we have the two part of the question. In the first part, our limit is approaching to the value of 0, and in the second part our limit x is going to approach 1. Alright, and in that case we need to find out the limiting value of the function f of x, and this is actually based on the choosing function. Alright, so here our f of x has two value. One is 2x plus 3 when x is less than or equals to 0, and another is 3 times x plus 1 when x is always greater than 0. Alright, so in these two conditions we need to find out the limit. We have to evaluate the limit. Okay, so I'm doing first here, but before solving I have to make a graph to make you understood this concept a little more appropriately. So let's say this is my x-axis, this is my y-axis. So according to the question, when our value of x is less than 0 or equals to 0, we have to choose this function 2x plus 3. The function f of x has the value of 2x plus 3. So let's say for a while less than 0, right? So I'm just for understood I'm making, just for understanding I'm making. I don't know exactly whether this is 2x plus 3 or not. Let's say this is f of x, which is 2x plus 3. All right, this is 2x plus 3, and this value includes 0 also, keep in mind. All right, that's why I'm making a little thicker. Oh my god, that's really thick. So whenever our x is less than 0 and x is equals to 0, we have to use this this function. All right, and one more function we have, whenever our x is greater than 0, whenever our x is greater than 0, it's not going to touch this line. All right, then that time we need to choose the function 3 times x plus 1. All right, so randomly I'm choosing. All right, I'm not sure about that, but let's say this function is here, just for a while. Let's say here. All right, but it's not going to touch that line. All right, let's say this is f of x equals to 3 times x plus 1. This is for all x is greater than 0. All right, so to find out the limit when x approaches to 0, we have two conditions. When x is approaching to 0, what do you understand from this? It means x is not equals to 0, x is slightly bigger than 0, maybe a little bigger than 0. All right, or maybe slightly less than 0. All right, slightly less than 0, but not exactly equals to 0. So since it is not equals to 0, when x is not equals to 0, so it will definitely bigger than 0 or less than 0. All right, it will be either right hand side of this line or either left hand side of this line. How much we don't know, so we have to take the approaching value from the left hand side as well as from the right hand side, and taking the approaching value from the left hand side is called finding the left hand limit, and taking approaching value from the right hand side is called finding right hand limit. So to evaluate the limit x tends to 0 f of x, first limit should exist. All right, and from the left hand side and from the right hand side, if we are getting both approaching value equal, then we can say that limiting value x equals to x tends to 0 is that exactly that value that we'll get it. All right, so first we need to find out the approaching value from the left. All right, so x tends to 0 minus slightly less than 0 when x is f of x. All right, and now again limit when x tends to 0 minus. 0 minus means we are little less than 0. So whenever we are little less than 0, we will definitely go for this function. All right, because when x is equals to 0 or less than 0, we have to choose this function according to the question. So it will be now 2x plus 3. All right, so further we can now plug the value of x, so it will be 2 times 0 plus 3, so it's 3. So our left hand limit is 3. Now let's check the right hand limit. If we are getting right hand limit also 3, then the limit exists and the limiting value will be this 3. If not, something is wrong. So let's find out the approaching value from the right hand side. All right, when x is slightly slightly bigger than it's 0 level, so it's slightly bigger than 0, that time let's say it's 0 plus f, 0 plus. So again limit x tends to 0 plus. Now see, when x is slightly bigger than 0, which option we need to choose? We need to choose this function 3 times x plus 1. So it is 3 times x plus 1. Now we can plug the value, so it will be 3 times 0 plus 1 it's going to be 3 times 1, that is 3. Hey, we got our left hand limit as well as right hand limit equal. It means limit exists. Therefore I can simply say now that limit when x approaches to 0. So whether you are approaching from the left hand side towards the 0 or you are approaching from the right hand side towards the 0, both time you are going to get the same value. Both time we are going to get same value, and that's equals to 3. Right, and this is the limiting value. This is the solution for the first question. And now for the second question, when x approaches to 1, all right, what is the limiting value? So for that also we have to find out both, you know, left hand limit and right hand limit. All right, we are solving now B. All right, so first let's find out the left hand limit. X tends to 1, slightly less than 1. So where will be 1? Let's say here is 1. All right, here is 1. So particular, let's see this one. All right, here x is equals to 1 exactly. But x is again, you know, when we are going to find out the limiting value when x approaches to 0, it means x is not equals to 0. So either it is slightly less than 1 or slightly more than 1. All right, so when it is slightly less than 1, we have to approach from the left hand side. You know, we have to approach from the left hand side. So we'll find out first left hand limit. Left hand limit when x is slightly less than 1, and definitely that time only one option we will have. Because this is when x is equals to 0 or less than 0, but for all x greater than 0 we have to choose this, and 1 slightly less, it means definitely we have to choose only one, this. All right, so it's gonna be limit x tends to 1, 3x plus 1. All right, and then let's plug the value. All right, so when we'll plug, it will be 3 times 1 plus 1, and it will be 3 times 2, that is 6. All right, now this is not the answer. This is our left hand limit. And now let's find out the right hand limit for the second question. When we will approach from right hand side, let's say if we are approaching from this side, right, what will be the limiting value? Let's find out. So f of x, and again this at this place we have to choose this function, right, because this is only for the 0 and less than 0. So again limit x tends to 1 minus, it will be again 3 times x plus 1. Let's plug the value. So it is 3, 1 plus 1, that is 6. Wow, wonderful. So from left hand side also we got 6, from right hand side also we got 6. So now I can by taking a very long breath, I can say that the approaching value of the function f of x when x is approaching to 1 is equals to 6, and that's our final solution. So one thing we need to keep in mind always, that whenever we're going to find out a limiting value, approaching value in these conditions, in where we have the options to choose, you know, we have to find out the most appropriate function according to the condition. Then that time you have to find out the left hand limit as well as right hand limit and check whether those are equal or not. If both limit are equal, the both left hand approaching value and right hand approaching value are equal, then the limit exists and that will be the limiting value, otherwise not. Okay, I will do one more question and I will show you there how the limit is not going to exist and we cannot find out the limiting value at that particular point. Okay, so I'll see you in the next video. All right, bye bye.